So recently I have acquired a couple of new acquisitions for the lab then, and this is one of them. It's the HP 5340A frequency counter. I've been looking for a frequency counter that can go, well, definitely in the range that I want, but this frequency counter goes up to 18 gigahertz, and I've been looking for one for a while. And I originally, I've been looking for probably 2 years now for a EIP frequency counter. People tell me you can pick them up for around $200 off eBay, but I've never found one for that price that didn't look like it had been dropped from a speeding car. And I was also looking for the EIP with the option of the power meter, because it's just a handy thing to have, because you can directly connect your amplifier or whatever to the EIP port for the power meter there. Just being careful not to put too much power into it, but you didn't need any special sensors or anything, and it was by all accounts quite accurate. But I found this on eBay 2 weeks ago now, and it was a guy in the US from Texas, and he had this up on the eBay auction there, well, to buy it now, and I put a best offer in for I think it was around £40, which is probably about $54, and he accepted, and it was another $80 to ship it here to the UK, which I didn't think was a bad price at all, because it is quite a heavy unit. And it's arrived. The guy did say that he didn't know whether it had worked. He never had a cable to plug it in, and he doesn't normally sell this kind of thing. He picked it up from a local school or college. It was found in a stock cupboard there, and it's got this little tag on here, but I can't make out what it says on there at all. So it's just sold as is, so I don't know really what I've bought for my £40 here, but I thought it'd be an interesting video to take a look at it and see, take a look on the inside and then put some power in there and see if it does actually work. Now, there is a good chance that it does work, although it looks in poor condition. It's really dirty on the front, and it's got some kind of rubbery goo on here. It's on the front here, and it goes down the back as well. And it's a good chance it may work, because colleges and decent schools would get frequency counters now that are the size of a shoebox that can do the kind of ranges that this can do. So this could well have been just shoved in a stock cupboard and forgotten about. But I wanted this one because it does fit in with my test equipment, and I did pick up a cheap Chinese one off eBay a couple of years ago now, but it was really poor, and I ended up selling that for half the price that I paid for it. It was no good to me at all. It was fine on the lower ranges below a gigahertz, but taking it above a gigahertz, it really slowed things down, so you had to really reduce that resolution on the screen, and it only went up to 2.4 gigahertz anyway. So what I'm going to do with this then is, before I'm going to put any power to this, I'm going to pop the cover off just to see if everything looks like it's in there, because sometimes especially in a college, if you've got a decent lab technician working at your college, it's quite feasible that they've taken parts out of this to make another unit work, and this was just a scrapper that they had in the stock cupboard. So I don't want to put power into it and have half the parts missing, and then we have a spark explosion and all the smoke starting to appear. So we just need to give it a visual check just to make sure everything's fine. But these frequency counters are really good workhorses if you can pick one of these up cheap. HP made these for quite a number of years, from the 1960s to the 1990s. The earlier ones have a Nixie tube here for the display. I think this one is probably from the mid 1980s, but they just worked really well, and you can put quite a bit of power into the input section of this without breaking it. I can't quite remember off the top of my head what it is, but it is quite high, and they just worked. You just switch them on, even though you know, a big organizations would pay to have it calibrated. They didn't really need any calibrating. They just, you know, there's not a lot you can do to this to make it go wrong. They really are a brilliant workhorse. So as I say, we'll take a look at the insides, but just the overall condition is pretty poor, pretty dirty, but all the knobs are in the right place. There's nothing missing here on the front at all. But one modification I am going to have to do for me to use it is the input connections are on the back of this unit, so I'm going to have to move the end connector for the gigahertz frequencies to the front here, just to make it easier for me to use here in the lab. I'm not particularly bothered about anything less than a gigahertz, so I'm not going to bother with the second connection there, but I'm definitely going to have to drill a hole in here and mount it at the front panel there. And here's the top of the unit then, and that rubberized gunk is all over the top part of the case. There's none on the underside, so if I do get this working, or if it works fine, then that should be easy to remove with some isopropanol. But it is like a rubberized gunk. It's messy. I'm not sure what it is. So now that I've got the cover off, then it's really surprising how clean the unit is. It doesn't look to have any parts removed from it, and there's no signs of any infestation or anything like that. It is extremely clean for its age, but the power section is what we're going to take a closer look at in a moment, prior to putting any power into this. And it looks like these two caps here might have been replaced at some time. I don't think they are originals, but this here is the ovenized frequency source, and this is a upgrade option you could get for this frequency counter. Being the ovenized version, you don't have to have this on quite so long for it to come up to a working temperature for its accuracy, and this was definitely an upgrade, so it's not the standard version we've got here. So if the frequency counter does work, that's a really nice positive there. So here's a closer look at the power supply section then. The first thing that catches my eye is how clean this fan is here, the cooling fan. It's not got a great deal of dust on it at all, and in fact the entire power section of this is relatively dust free. Now somebody could have cleaned this out prior to trying to fix it in the past, or it could have just not got a lot of use before it was decommissioned, but it is exceptionally clean, the fan on there. So with something like this then, that's a complete unknown, you want to start at the power supply section here and just visually inspect everything. Look for areas of burning or charring, anywhere that a spark may have jumped across, any blown fuses, and the condition of the caps as well. Make sure there's no bulges, but everything looks quite neat and tidy in here. None of the wires seem to have been melted, and everything looks in place. It hasn't been interfered with at all. Also look at the solder joints as well, just visually check for repairs. There might be good repairs, or it might be repairs that somebody's tried to do to get this unit working. So again, it's a bit of a detective work, trying to find out, you know, something about the history of this when it's a complete unknown. And pay particular attention as well to the high voltage resistors here and here, because they take a big whack if anything goes wrong with the input power. So generally though, it looks really neat and tidy. So next then, what I'm going to do is just pop out the low voltage cards here. Basically this is the high voltage on this side, and then these cards here distribute various low voltages out to all the different parts of the frequency counter. Some may want 15 volts, some may want 12, some may want 5, and this is what these boards do. So what I'm going to do is pull them out one by one, and again just visually inspect them, make sure you know, taking a look, see if there's any evidence of burning or failed components. So here's the first board then, and all the components look fine, in really good condition. We haven't got half a resistor in place where there's been you know, a catastrophic failure and it's blown off the board. All the traces look really nice, no burnt traces. So the first board looks okay on visual inspection anyway. And here's the second board then, and again this one looks fine. All the traces are in place there, the gold plated traces. It's really nice. I really do like vintage electronics, but electronics in general is probably one of my weakest subjects. I've only ever learnt enough to get me by on you know, say constructing RF stuff. You know, I'm not a electronics expert. It's only what I've learnt you know, to get me by on other things. But here we've got this heatsink here as well. Now this butts up in the slot there, and this flat surface here is directly in the path of the fan, so that's how they're getting some cooling onto here. So you know, really nice design. I just love the way the traces are laid out as well on vintage electronics. And here's the third board, again very nice. We've got some wider tracks here, so that kind of tells us we're dealing with a higher voltage with this board. Something else that I'm checking as well that I haven't mentioned is check the back and look for signs of evidence where somebody may have desoldered and replaced some parts on these, but they do look original to me. It doesn't look as if anybody's done any kind of work on this in the past. And here's the final board then, and again on the surface it looks to be in really good condition, but there's a diode here and it did catch my eye. One of the legs looks as if it's had a bit of charring on it, and these two transistors here also look as if they've been taken out or replaced. If I flip it on the underside, there seems to be a little bit of flux residue in these areas here. Doesn't look as neat and original as the soldering we've seen so far. So possibly here and here they've been replaced sometime in the past. I don't know. Just looks messier than the rest of it. It may have been in the factory and the flux residue not cleaned off properly, but you know, if it doesn't work, then you know, this board maybe something I'll look at first, especially if it's a low voltage problem rather than the high voltage power supply. So everything looks fine on the power supply side, and I'm just visually inspecting this area here. And what's interesting is all this board here and this board drive the characters at the front, on the front of the display, and this space here would have originally been taken up on one of the earlier versions from the 1960s, mid 1970s, that ran a Nixie tube for the display, and all this space would have been needed for the high power rails to drive those Nixie tubes. Now the chassis itself, they never changed. HP just kept the same chassis dimensions as it progressed over the 4 decades that they actually made this during. And you know, because of that, we've got this wasted space here, because originally all the high powered stuff would have taken that space up. So I just find it really interesting, and HP would have saved themselves a lot of money by not having to redesign this case as well. So I'm going to power this on now that we've visually checked the power supply. But before I do, I thought it'd be nice to take a look at this board. It just caught my eye. This is part of the frequency mixing section, and we've got a oscillator here, and it's just beautiful. It's gold plated, quite large. I just love vintage components like that. It really is a work of art. All the gold plating on the circuit board itself, and all the through hole you know, components from the 1980s and 70s. I just love the way they look and are laid out on a board like this. I really like this part. If this doesn't work, I'll desolder this and keep it, and see if I can integrate it into something in the future, some kind of mixer for instance, because I do want to make my own tracking generator for my spectrum analyzer, and I'm saving vintage parts to create that. But it really is a work of art. And I almost forgot to check the underside before I powered it on. You know, most people take the top panel off, but there's quite a lot going off on the underside panel as well. And here we can see the taps for the transformer coming off. But just again, general condition, it seems to be fine. Doesn't seem to be being tampered with or any major repairs being taken place. So I'm going to power it up and see what happens. So it's time to power it up then, and keep our fingers crossed. So I'll just switch the mains electric on. And we've got no magic smoke at the moment, so let's turn the unit on. And look at that. So that seems to power up fine. It's not making any strange noises. We've got a nice bright display here on the front of it. I think there's a little bit missing there, but that's probably due to dirt when I give the front panel a clean. But so far so good. So let's feed in some signals and see how well the calibration is on the frequency counter, and see how quickly it responds to the signals. Now I'm using my sweep generator here on CW rather than using my signal generator, just because that's in the same vicinity here, so I can get the two into one shot rather than flicking backwards and forwards. And the frequency counter has had a good 20 to 30 minutes to really warm up now. Now I'm feeding in a 1 GHz signal here, and as you can see on the display, it's coming out at 986.35 GHz. Now that's a little bit out, and it's not due to the loss in the cable either. The loss in the cable wouldn't be that much, so it's a little bit out at 1 GHz. And the frequency scale on here, the resolution scale, sorry, does work really well. It latches on and engages, so we can see the resolution of that frequency scale. So let's go up a little bit more, and let's put a signal in of 2 GHz. So here we are at 2 GHz then, and it's 1.9844 GHz, so a little bit better than it was down at 1 GHz, but again a little bit out, probably due to calibration. I'm not sure how you calibrate the frequency counter. I'm going to have to download the manual and the operating manual and read through that and see what you have to do. But I do know that this sweep generator is calibrated. A good friend of mine took this in to work with him on a weekend, sneaked it in through the back door and did a full calibration on it for me, so I know that this is spot on. So that may be a little bit of cable loss, because it does seem a little bit better than it did at the 1 GHz, but you know, if it's been sat in a cupboard for years and years, and it's an old piece of equipment, 30 years old, then the calibration is going to be out. And there is a calibration sticker on the front of the frequency counter, and it was last calibrated in 1994. So let's go up to 3 GHz then and see how well it handles that. Well, it seems to be getting better and more accurate as we go up the scale, because it's 2.993 GHz there, so it's definitely not out as much as it was at 1 GHz and 2 GHz, sorry. So it seems to be getting better as it goes up the scale. So let's try 4 GHz then, and again 3.992. I'm happy with that. A little bit of cable loss, you know, you can add a 3 or 4 digits on for at 4 GHz for the cable loss easily. So it is definitely getting more accurate the further up the scale we go. So let's try 5 GHz then. Yep, happy with that, and we'll go all the way up the scale now. Let's knock the resolution back a little bit. That's better. It doesn't like the higher frequencies at that resolution, which is another reason why I've got to read the manual. So we're nearing the ceiling now of the 18 gigahertz of this frequency counter. So there we are at 17.96, feeding in a 18 gigahertz frequency. So definitely a little bit of cable loss, but it is performing better at the higher frequencies. So there's definitely going to be some calibration to do on this. Finally, let's just feed in 19 gigahertz and see what happens. So it's working at 19 gigahertz, 18.96 gigahertz. So let's feed in 20 gigahertz. That's the maximum that my sweep generator will go up to, and we'll see if it displays that. And it's definitely displaying that as well. So I'm thinking that possibly this might have the option to 23 gigahertz, I believe the option is. There's no option numbers on the back to state what options are in the frequency counter, but we've definitely got the option of the stable time base on there, and the option would have been an option for the connections at the back rather than the front. So possibly the option for the higher frequency as well. I don't know, because there's no little plates or any kind of stickers on the back to tell me. Let's just manually turn the sweep generator up now, because it does go a little bit further. So 20.4 gigahertz, and as you can see, it's displaying it quite nicely on the frequency counter there. A little bit of loss, but not a great deal, especially when we're at these higher frequencies. You expect a little bit more loss. So I'm quite happy how the frequency counter is performing. So before we finish then, I just wanted to quickly show you why I prefer buying an older piece of equipment like this, and why I got rid of that cheap one off eBay that I got a few years ago. Because the cheap one, the update speed was so slow, it was like watching paint dry. Probably fine if you just fed a normal signal in there without changing it, just if you wanted to find out what frequency, say, a transmitter was transmitting at. But if I change the frequency on the sweep generator here by this wheel, you should see it update fairly quickly on the frequency counter as well. There won't be a great deal of lag. So you can see it's definitely keeping up with the readout on the sweep generator there. Really pleased with that. And if I knock the resolution down a little bit as well, it then becomes even quicker. So I'm really pleased with that. A little bit of calibration. I think I've got another piece of nice test equipment to use here in the lab. So first of all then, I must apologise. I should have really put my glasses on before reading the calibration sticker. I thought it was around 96, but I was only a couple of years out. It's still 18 years ago. But look at the calibration sticker. This frequency counter has actually come from NASA. So I had to do a double take when I put my glasses on and read the calibration sticker. Then to come from NASA, that's unbelievable. I purchased this on eBay. It's come all the way from the States, and it's arrived here in South Yorkshire in the UK, and I've actually got a piece of equipment in my lab now that was originally purchased and used in a NASA laboratory. How cool is that? So this calibration sticker then, after I've given it a good clean, I am going to be sticking this calibration sticker back on the unit itself. I'm not going to be throwing this away. It's unbelievable, definitely, you know, to pick up a piece of equipment that was originally used in you know, at a NASA laboratory. It's one of the things about collecting, you know, older equipment is they've got a history, and you know, sometimes you leave it up to your imagination what they might have been used in, whether it had been a university, college or whatever. But this with the NASA calibration sticker, you know, I was really gobsmacked when I read this. I really had to do a double take. So I've removed the side panel off to get easy access to the main connector here for the end connector, because I'm going to remove it from the back there and have it on the front. So I've got this rigid coax, but I just wanted to show you how loose it is. I haven't tightened this up or slackened it up in any way. This is how it was. And this nut here, the 10mm nut, is quite loose, so I don't know if this may have played any part in the slightly poorer readings that we got from 1 GHz up to about 6 GHz. And I'm not sure about this part either, whether it's just a coupler or it could be some kind of attenuator. Before I took the side off, I did think it was some kind of diode, but it's not. It's either a coupler or it could be a small attenuator, so I'll have to test that as well. But basically I'm just going to reuse this rigid coax, cut it down and modify it so we can have a connection here in the front. So I've just googled this part and it's got a HP serial number on there, and apparently it's a RF limiter, and it works from DC up to 26.5 GHz, and there's somebody on eBay trying to sell one of these at this moment and they're wanting $191 for it, so I better keep this safe, and I'm going to have to incorporate it back into the modification. So I'm going to have to save the end connectors on the rigid coax and put it all together to include that back into the circuit again. But it's not going to be too difficult with this modification, because the hole in the aluminium case is already down in there, so I've just got to cut a hole in the plastic at the front, so it's not going to be as difficult as I first thought. So in modifying the front connector then, I've decided to use this bulkhead end connector that I've got here in the lab, and this has got a screw type connection, so there's no soldering that has to be done. It just pops in there like that. But I'm using such a short piece because there's not a great deal of room to play with. Now that I know I need to incorporate this RF reducer here, but I've got a bit of good luck with this modification, because this is a three-way coupler that we need to connect to, and originally this was in line on the coax as you saw earlier on, but because it's standard connections, I can just screw this directly to the port on the coupler here, and then I just need to make this short length of rigid coax here to connect up into that, and there's just enough room to connect all this up, and this is just long enough to connect out to the end connector on the front panel now. And this was just pure luck. This was a piece of rigid coax that I've got in my spares box, and originally this part of the coax was pointing this way, so it was a little bit like a U-shaped piece of coax, if you will, but I put this end in the vise and I gave this a bit of a twist, and I just cold bend it, and it's just worked out really well. It hasn't snapped or anything like that. I've used this stuff a few times now to modify a couple of items here in the lab, and I found that putting a little bit of heat into it makes it crack or snap. It doesn't make it turn out too well, so I've just cold bent it into the position I want, and it's worked out really well. It's the correct size and everything, so I don't have to go around cutting anything. I just need to put this connector on here, solder it onto here, so then we can connect it up to this little RF reducer. So I've completed the modification relatively easily, with the look of the coax, the rigid coax being the correct length and everything, and I've got the end connector on the front here. That's really secure, but there's not a great deal of room down here, and I've got the connectors here just making contact with the chassis part of this switch down here, this lever switch. It's not making contact with anything like the connection wires here for the switch itself. It's just grounding itself to the switch, but this switch is going to be grounded to the chassis anyway, and this coax can touch the chassis obviously, because that's down to ground anyway, and the original coax was making a connection with the chassis as well, so I'm not too worried about that. Just really tight on the room down there, but it's worked out quite well. And as far as what's left of the old rigid coax, I'm just going to leave that in situ. There's no real reason to remove this, but I'll leave it there because you never know in the future. I may change it back if having a connection at the back better suits my needs. It's going to be a lot easier to modify it back to how it was originally anyway. So here's the frequency counter in the setup then. It's really turned out to be a nice frequency counter. It's cleaned up well. I did crack the front perspex there on the display, putting it back in because the plastic is so brittle. I cracked it there, but I've glued it together with a little bit of super glue, and because it's just to the side of the display, it doesn't really, you know, interfere with anything. But it's cleaned up to be a really nice frequency counter for the money, and just the fact that it's got that calibration sticker there that I've put back into place, because originally it was used in a NASA laboratory, has really made that for me with this piece of equipment. I mean, even if I couldn't get this working and I had to purchase another one to use parts to get this working, I think I would have done that rather than trying to find another working one, just to get this up and running again, just due to the fact that it was once used in a NASA laboratory. Anybody who comes into my lab now, this frequency counter will definitely be a talking point. And now that I've cleaned it all up and I've got it running here, I've had it running for about 45 minutes now to really warm up. The difference there, the loss, is not great at all. I don't think it needs any kind of calibration. The small amount of loss that you see there, I'm putting in 2.4 gigahertz here, and it's displaying 2.393 gigahertz, and I am using this splitter to also send it off to the spectrum analyzer. So this splitter has a little bit of loss in it as well as these cables. So I'm pretty pleased how accurate it is, really, definitely for its age as well. It was last calibrated in 1998, so it's 18 years ago. And that just goes to show how well made these frequency counters were. If you can pick one of these up pretty cheap and working, they really are a good workhorse. If you don't mind the space that it takes up, HP really did put a lot of engineering into this, and that shows by the fact that they were kept in operation for almost 30 years. HP produced this line of frequency counts with just a few minor changes with the display output and a few other things on the inside. And also, because this frequency counter was used originally in the NASA lab, it is spec'd out with everything. I've done some checks afterwards, and this does have every single option that was available for this frequency counter at the time. So again, a bargain for the money I paid for it. So I hope you enjoyed this video, and it just goes to show that if you're patient enough on eBay, save your searches and just keep checking them every now and again to see what comes up, you can land on some decent equipment. And again, as I've said previously in other videos, you know, don't be shy to purchase something like this off a seller that doesn't normally sell something like this, because they can drop on. They will probably just power it up. They can't do any kind of checks on it because they don't have the equipment to test if it's working or not. And sometimes you can take a chance because it's at a slightly lower price than it would be from a main seller of this kind of equipment. And you can drop on lucky sometimes. I mean, if this didn't work, I could probably just put it back on eBay as a spares or repairs item and be honest with it in the description, and I could have probably got my money back on this anyway. But as it turns out, it's a fully working frequency counter, and it's come from NASA. So if you did enjoy the video, please give it a thumbs up. Any comments or questions, then drop them below. I'll do my best to answer them, and hopefully you'll join me on the next one.